Hello and welcome back to P Academy. So in this video we're going to be looking at an example under H parameters. So in the previous part we looked at an introduction to what H parameters is, and we've looked at the formulas and the circuits that are associated with H parameter. So before we proceed, there is a part that I didn't actually mention in the previous part of the video where during the introduction is the matrix form of the equation 1 and this equation 1 and equation 2. So if you want to write it in matrix form, you are going to be having something that looks like this. So this is v1 i1 equals to h11, and this will be h12, this will be h21 and h22, and then over here we are going to be having i1 and v2. Okay, so if you are to put it in the matrix form, it will look like this. So if you should expand this if you should expand what we have here in matrix form, you're going to be having this over here. Exactly. So with that, now let's go into the video for this, the example in this that we're going to be looking at in this video. Okay, so he said we should find the hybrid parameter for the two-port network above. So this is the network above. So this diagram that you are seeing here, this is a typical question that you're going to see under H parameters. So now let's see how to solve it. So the first thing I want to do is let me redraw the circuit, because the circuit doesn't have well enough information. Like this particular circuit, there's not well enough information, but this is how you're going to see it. So let's see how what information we are going to be adding from our own end so that we can solve the question. So let me redraw it. We have something like this. Alright, so this is how the diagram is looking like in the question. So what are the other informations that we need to add? Just like we did when we did Z parameters, Y parameters. One thing you notice that they won't have polarities, but from the circuit diagram we looked at in the previous video, we know this will be our positive and this will be our negative terminal. On the input side will be our positive and this will be our negative terminal. And then we have our I1 and our I2. So if you look at the diagram we are giving, I1 and I2 in this diagram, you can see they didn't actually specify what I1 and I2 is, but in the regular H parameters, so we already know what our I1 and our I2 is and the direction. So this is it, and this is the direction for our I1, and then for our I2 is towards this direction. Exactly. So with that now, since we already know that this direction of our I2 and this is the direction of our I1, so definitely the current that will be flowing through this particular branch here will be a combination of I1 plus I2. Exactly. So now with this information, we can go ahead to solve this circuit using, let me use mesh analysis. So let me take so this will be our V1 and this will be our V2. Are we good? So now using mesh analysis, let me take the direction of my current for this towards this direction in this mesh here, and then for this second mesh, let me use this direction. Exactly, that's anti-clockwise direction. And the reason why I want to use anti-clockwise and clockwise is that I want to make sure that the V1 is positive. Exactly, if I should take it in this clockwise direction, the V1 is positive. If I should take the second mesh in anti-clockwise direction, our V2 will be positive. I hope that makes sense. Okay. So personally, I feel it will make the work much more easier. You can use it the other way around. So now from mesh 1, now, so that means you're going to be having V1 . So let me also add the polarity to the circuit before we proceed. So this would be in this direction to be plus minus, exactly. So for this will be our plus and our minus, and then our plus and our minus. Okay. So just in case you're confused, I've explained what I did here on the video on mesh analysis. So that explains the polarity that is going on there. Okay. So this will be plus V1 and then this will be minus 3I1 minus 10 into brackets I1 plus I2 equals to 0. So that will be V1 is equals to minus 3. Okay, no. So that's V1 minus 3 I1 minus 10 I1 minus 10 I2 equals to 0. So if we should simplify this, we are going to be having v1 is equals to, so this is minus 3i1 minus 10, that will be 13. So if you come to the other side of the equals sign, it will become plus 13i1 then plus 10i2. Exactly. So let's take this as our equation 1. But one thing you will see is that this equation that we're having here is similar to the z parameters. So that means from equation 1 we can say this our z11 is equals to 13, which is this 13 here, and then our z12 is equals to 10, which is 10 that we are seeing here. Exactly. Okay, so just take note of those. So now let's also do the same thing to our mesh 2. So from mesh 2, now, that will be v2 minus, so minus 2i2. So we are going to be having v2 minus 2i2 plus 4i1. Exactly. So plus 4, so okay, there's a polarity, and that was minus and plus 4, then minus 10 into bracket i1 plus i2. So are we good? So you remember, once you are coming towards this direction, and then once it comes here, so that will be minus 10 i1 plus i2, because that's the current that is flowing through this particular branch. Exactly, that's why we're having i1 plus i2. Alright, so now let's simplify this. If we should simplify this, you are going to be getting v2 minus 2i2 plus 4i1 minus 10i1 minus 10i2 equals to 0. Exactly, so there should be equals to 0 here. Alright, so now let's simplify this. We are having v2, this is plus 4i1 minus 10, now that will be minus 6 i1. For i2, that will be minus 12 i2 equals to 0. So if we should rearrange it, that will be v2 will then be equals to 6i1 plus 12i2. So let's take this as our equation 2. So if you should compare what we are having here with that of the z parameters, we can conclude that our z21 is equals to 6, which is this 6 we are seeing here, and then our z22 is equals to 12. Exactly. So we are not done yet. Remember, what we just got in now is our z parameter from the question. Exactly, but the question is asking us to get our h parameters. So now what you can do now is conversion. So that is converting from our z parameters to y parameters. And in the previous video I gave you the formula that you are going to use to do that. So let me just quickly write it here. That so conversion of z to h parameter, and remember, what we are going to need is our determinants. So let me first write our z. So remember our z11, z12, z21, and z22. So if you have to put it here, so our z11, that's 1310. So 13, 10, then 6, and 12. Exactly. So that's equals to our z. So if you have to look for the determinant of z, so that will be 13 times 12 minus 6 times 10. Very good. Okay. So in doing that, 13 times 12, let me see. That's 156. Then minus 60. So this will be 96. So that means our determinant is 96. So now let's go ahead and start to do the conversion. So for us to get our h11, so from the conversion, I shared it earlier in the previous video. So for you to get our h11 using z values, so it's going to be the determinant of z divided by z22. And what would that give us? That's 96 over, what's our z22? Z22 is 12. 96 divided by 12. And what would that give us? will give us 8. Exactly. And don't forget, if you are looking for the h parameters, that's the hybrid parameter, the unit is in ohms. For this now, the unit will be in ohms. Okay, hold on. Okay, so that will be 8. So now let's look for the h12. So for the h12, that was z12 over, yeah, it will be in ohms. And this is okay, ohms. You can just use the symbols. So let me just talk about that real quick. So while calculating for this determinant, the z, remember this is more like 13 ohms, 12 ohms, 10 ohms, and then 6 ohms. So if you are multiplying this, you are going to be having ohms and ohms. Let's do that, will be ohms square and then ohms square. Exactly. So this 96 is just same. It's just like having, if you have to put the unit, it's ohm square. So this is going to be like ohm square divided by ohms. So this can cancel, this will be left with ohms. Exactly. All right. So now for h12 is that z12 over z22. So what's our z12? Z12 is 10 and then z22 is 12. So that means we're going to be having 10 divided by 12, and that will give us 5 over 6. Now this won't have any units because the units here, they are cancelling out. Okay, so now let's get our h21. So that means our h21 is given to be minus z21 over z22. Okay, so let's see what's the value of our z21. That's 6 and our z22 is 12. So that will be minus 6 divided by 12, which is equals to minus 1 over 2. So this also won't have any units. And then the last one is h22, which is 1 over z22. Okay, so that means 1 over, what's our z22? I think it's 12. So this is it, our z22 is 12. So that's 1 over 12. So, and then this can be, okay, yeah, just 1 over 12. We can just leave our answer like that, and then the unit will just be, okay, let me just write it like this. Exactly. So with this now, we've been able to get the hybrid parameters for the circuit. We've gotten our h11, h12, h21, and h22. Exactly, using the conversion method, getting the z parameters, and then we convert it. Now, if you don't want to use that method, you can just okay, I don't just want to go through that method in this video. So you can just decide to do some from equation 1 and equation 2. So what you just do is you make I1, I2 the subject formula. Once you make the I2 from equation 2 the subject formula, you come and substitute it into equation 1. Exactly. And then once you do that, you just play around with the equations so that you can get the value of V1 and I2. Exactly. All right. So, but with this, you can easily follow this step. I believe this is much more simpler and straightforward. So that's why I'm sharing this. So if you find value in this, please give it a thumbs up. And if you have any question or doubts, do let me know in the comment section below. So thank you very much, and I'll see you all in the next video. Thank you.